Hello everybody, this is the Bonding Properties Lab where we are answering the question, how are ionic and covalent bonds different? You should have your procedures available already. A data table which has calcium chloride, phenyl salicylate, potassium iodide, sucrose, sodium chloride, and we did have urea, but we substituted ascorbic acid, which is vitamin C, instead. Now we are going to be testing the melting point, the solubility, and the conductivity of all three of these. Some of them will melt, some of them will dissolve, and some of them will conduct electricity, but not every single one of them. I have them labeled 1, 2, 3, 4, 5, and 6, so I can better keep track of them. I have 1 through 6 labeled on my solubility tray, my well plate, and on this aluminum foil platform where we're going to be melting each separate chemical. So let's go ahead and get started. I'm going to move my I'm going to move my platform right over this candle. And right off the bat, we're seeing that number 2, which is phenyl salicylate, quickly melts and bubbles. I'm going to move this over to just under number 1, which is calcium chloride. Calcium chloride's not doing anything. We'll leave the flame underneath calcium chloride for just a little bit longer, but it's obviously doing nothing. That phenyl salicylate is still evaporating. It must have a very low melting point and a very low boiling point. So calcium chloride hasn't done anything. We're going to move on to number 3, which is potassium iodide. So I'll move my flame just under potassium iodide. And what you're seeing happening is the sugar, the sucrose, which is number 4, is actually starting to get hot because it's so close to that flame, and it's turning brown and melting already. Potassium iodide, on the other hand, is doing nothing, a lot like the calcium chloride. So let's go ahead and move this to right under the sucrose. Be sure to write down any observations. So we've got a pretty good idea if sucrose melts or does not and what happens. So let's go ahead and move on to the 5th one, sodium chloride, which is table salt. We'll move this right under sodium chloride. This is table salt. I wouldn't expect it to melt, but we'll test and see. Table salt's melting point is listed as 1,500 degrees Fahrenheit, or roundabouts. I don't think our tiny little candle is going to get that hot, but we'll still test it anyway. Again, just like calcium chloride and the potassium iodide, nothing is happening. It's not doing anything, it's not melting, it's not even turning color. So we'll go to the last one, ascorbic acid, which is vitamin C. Move that just under number 6. And we'll watch to see if it does anything. It does seem to be doing something. It looks like it's turning brown. Let's try moving this a little bit closer to the flame. So this flame is right underneath it. We do have it melting. We do have it changing colors. It's not as quick as the sucrose was, though. And there is some smoke coming off of it. That sugar's still boiling. It's getting hot again. So I think we can say that our ascorbic acid did melt and did change colors. There's a lot of it on there, so that's probably the main factor as to why it didn't go faster. I'm going to go ahead and blow out this candle, and we'll move on to our solubility test. Well, I have each one in its own well. We'll start with number 1, calcium chloride. I'm going to put distilled water in there. We want to see if it's going to dissolve completely, or if it will dissolve partially, or if it's going to not dissolve at all. Calcium chloride. It looks like it does dissolve completely. I don't see anything left. Phenyl salicylate, number 2. No dissolving at all. It absorbs some of the water and it just kind of sits there. Doesn't do anything. So no solubility for number 2. Number 3, potassium iodide. There is some that's still left in there. If it dissolved, I don't know if very much dissolved at all. So we could say some solubility. Number 4, that's sucrose, regular sugar. And I don't see any dissolving for number 4. Again, it's just sitting there. Maybe over time it will dissolve, but just as it is, I'm not seeing any change. Let's go to number 5, sodium chloride, table salt. There's still some in there, but it looks like it's mostly dissolved. So we can say that sodium chloride dissolves very well. Let's go to the last one, ascorbic acid. So number 6, ascorbic acid, it looks like some of it dissolved, but not all, so partially dissolved. So going back to look at them all, number 1, calcium chloride, all of it dissolved. Number 2, phenyl salicylate, none. 3, potassium iodide, it looks like it partially dissolved. 4, maybe some dissolved for sucrose, it doesn't look like much though. 5, sodium chloride, most of it dissolved. And number 6, ascorbic acid, it looks like it partially dissolved as well. The next step is to test conductivity, and for that we have a conductivity tester. We're going to put these 2 metal leads into the solutions that we've already made. If it lights up with only a red light, we have a low conductivity. If the red light lights up and the green one lights up also but is dim, we have medium conductivity. And if both red and green light up brightly, then we have high conductivity. So let's test that right now. Number 1, both of them are quite bright. So number 1, calcium chloride, has very good conductivity. I'm going to dry off my leads, make sure I'm not, for lack of a better word, cross-contaminating things. Phenyl salicylate next. The red one's on and the green one is on too, but it looks very dim. So we'll say medium conductivity for phenyl salicylate. Again, I'm going to dry off my leads. I'll go to potassium iodide now, number 3. Very bright on number 3. So potassium iodide has a high conductivity. And on top of that, when I stick this conductivity tester, which is sending a small electrical current through, I'm seeing a change in color within the solution that wasn't there before. So that's definitely something worth noting. Let's dry this off. Try the next one, which is sucrose. Let's see if sugar water will conduct electricity. Low conductivity. That red light comes on, but there's nothing on that green light. So, low conductivity for sucrose. Sodium chloride is next. Salt water. Both of them light up quite well. High conductivity for sodium chloride. Last one, ascorbic acid, vitamin C. This one, red light's on, green light is dim, so medium conductivity. I would expect that some of these would have no conductivity, but that doesn't appear to be the case for what I've tested. There could be errors, there could be something mixed in with any of these chemicals that caused it to not do what I expected to, or maybe I was just wrong. It's up to you to decide. You should have been documenting the results, your observations, putting them in your data table, and this should help you with your lab report. If you have any questions, feel free to send me an email, or you can ask me in class.